Okay, so here we have a little scenario. A brand name has a 40% recognition rate. The owner of the brand takes a small sample of 8 randomly selected individuals, and we want to know the probability that exactly 7 of those 8 individuals recognize the brand name. That seems kind of complicated at first, but if we start thinking, it's actually not too bad to deal with. So for starters, there is a fixed number of trials. Right? Fixed number of trials, how many? There's 8, right? Each customer that they ask is a trial, right? They are independent. If they were randomly selected, they're independent, right? There is a fixed probability of success. Right? We assume that each customer we approach, there's a 40% chance that they recognize the brand name. And then 4, right? What's the other criteria? It's that each trial can be broken into success or failure, or a yes or no. So either they recognize the brand or they don't. There's success or failure, right? So either one is a yes or no, or a success versus failure, right? And so that makes it a binomial probability. Alright, and so what that means is, I'm going to clear a little space for myself here. Alright, what that means is we can use the formula, right? So the probability that the random variable x, right, or the number of folks that recognize the brand name is equal to a given numeric value is equal to n choose x, right, times p, the probability of success raised to x, the number of successes, times 1 minus p, the probability of failure, raised to the n minus x, or the number of failures. Right, so let's see what that looks like in this context. Let's jump to the next slide here. And so n is the fixed number of trials. Well, that's 8. There were 8 individuals, right? X is the number we want to be successful, or the number we wanted to recognize the brand, and that's 7 in this case. What's the probability that an individual recognizes the brand? 0.40, right? 0.4. And so that's really all we need. All right, so the probability that exactly 7 customers recognize the brand name is, right, so 8 choose 7 of them to be successful, times, right, the probability of success raised to the number of successes. We wanted 7 people to recognize the brand, right, times the probability of failure, or 1 minus 0.4 is 0.6, right, raised to the, right, n minus x, or 8 minus 7, and that's really just 1, right? So I'm going to just make that 1 for simplicity's sake now, right? So you'll notice, change my ink color here, that these two, right, this is x and this is n minus x, so if you add them together they should always add up to n, right? Because you're accounting for every individual that's or every individual trial. Okay, so this is a combination which we learned how to compute earlier, right? And we should do that using our calculator or Excel, and then we just multiply it by 0.4 raised to the 7th times 0.6 raised to the 1st, which is just 0.6 in this case, right? So if we do go to our calculator with this, the way that we enter it is I'm going to say 8. I'm going to go to the probability menu. Remember, you go Math, you arrow over to the probability menu, and then you arrow down to NCR, and you select that, and so this will come up on your screen, and then you choose, right, R, so 8 choose 7 times 0.4 raised to the 7th times 0.6 raised to the 1st. Now I really don't need the raised to the 1st, right? I really don't need this in that particular case because it's just, why won't that delete? That's interesting. Huh. So I'm going to go ahead and erase these guys. Right? But you'll notice that I didn't put a whole bunch of parentheses or anything in because your calculator automatically follows the order of operations. It's already going to do this exponentiation before this multiplication because when I hit the caret key, right, it knows that it needs an argument, it needs an exponent, and it automatically interprets the 7 as that. And so my backspace keys, or my undo key, is not working right now, which is a little frustrating, so that's why I'm having to erase these things, sorry. But anyway, if you enter that into your calculator and then you hit enter, you will get the correct answer of 0.0079 rounded to the nearest 10,000th place, right? We round probabilities to 4 digits typically. Okay? So hopefully that helps clear some things up for you. So now I want to throw another little curveball at you here. And what if I was to change the probability up on you a little bit, and instead of saying exactly so many customers, I said fewer than 4. Well, that means there are more possible outcomes to consider, right? So when I say fewer than 4, what we're talking about is the probability that x is less than 4, not equal to an exact number. But what we realize is that's equivalent to, right? So here, let me do this instead. Let me write. Okay, so x being less than 4 is equivalent to saying x equals, right, 0 or x equals 1 or 2 or 3 or, right, etc. Or, well, just I guess we end at 3 in this case. Fewer than 4 would be 0 or 1 or 2 or 3, right? So that's 4 different binomial probabilities to compute. So in order to actually calculate that probability, we do what we did on the last one, but we do it for probability that x equals 0, right? Or means add in probability, and so plus the probability that x equals 1, so we do it again. Plus the probability that x equals 2, plus the probability that x equals 3. And so we compute all 4 of those and we add them up. And that's how you would deal with one of these. Right? And so what I'm going to do is I'm going to link you to, there are some functions. There's a built-in probability distribution function on your calculator that will help you do things like this. And so I'm going to link you to a video that will help teach you how to do those.